Today we're going to do systems of linear equations in 2 and 3 variables, and then distance and midpoint formulas and circles. So this is a review lesson. Everything is review. We might apply it in one problem that's a little bit different than what you've seen, but most of it should be review for you. So the first one right here says to solve the system of equations using the substitution method. So whenever you use substitution, you take one variable and plug it into the other. So there's this little chart that you can use if you'd like. If not, it's not a big deal. So you put one equation there, and then the other equation goes here. And because this has a y and this has a y, you can take whatever it equals and swoop it into that one. So we get negative x minus 1 equals 4/3 x minus 8. And because I have a fraction here of 3, I'm going to multiply both sides by 3. And the reason why I'm going to do this again is to get rid of that. So on this side I get negative 3x minus 3, and on this side I get 4x minus 24 when I distribute. And then I'm going to combine like terms, so I'm going to move that negative 7x over there, and I'm going to move that negative 3 to the other side, where it becomes positive when I add it. So then positive 3 plus negative 24 is negative 21, and then divide both sides by 7, and I get x equals 3. Now this asks me to solve a system which, because this is in 2 variables, it's where 2 lines intersect, so I need an x and a y coordinate. So I'm just going to take this 3 and plug it back in there, and then I end up with y equals negative 4. And the notation that you're going to use whenever you're doing these solving systems is you're going to put it in point notation, so x and then y. So that's what you need to do to get full credit, is put it in point notation. Okay, for the next one, we're going to use the addition method. This is also known as the elimination method. And what you're going to want to do first is put these equations in standard form. So the way that you're going to do that is you are going to get your x's first and then your y's, and then it should always equal your constant term. So this is the standard form of a linear equation. Then you're going to do the same thing over here, and we're going to get 3x plus 5y equals 17. And then from here, what I'm going to do is use elimination. And in order to eliminate, they have to have opposite signs and be the same number. So for example, if I want to eliminate the x's, this would need to be 6x and this would need to be negative 6x. So that's what I'm going to do. The other thing that you can do is go, oh, you know what? Since one of these is already negative, I'm just going to choose to eliminate the y's instead of the x's. So actually, I think that's what I'll do. So what I'm going to do first, let's see. I'll go ahead and multiply it actually by, I'll eliminate the x's first. So the first thing I'm going to do is take this and times it by 3. I'm going to take this one and times it by negative 2. So what I get, I'm just going to draw a line because we're going to be doing something in a second. When I multiply this by 3, I get 6x minus 21y equals negative 51. So that's 3 times negative 17. And when I do this one, I get negative 6x minus 10y equals negative 34. And that's negative 2 times 17. And then now you can see when I add those two equations together, I eliminate that one, and I end up with negative 31y equals negative 85. And when I divide, I get y equals 85 over 31. And it's no longer negative because a negative divided by negative is positive. So here's something that you probably haven't done in Algebra 2 or in Algebra 1. Usually once you find your y, you plug it back into the equation to find your x. But instead of doing that, since I have a fraction and that could kind of get messy, I'm just going to do the same thing I did with this one, but I'm going to do it with y's. So to eliminate the y's, this one needs to be multiplied by 5. So same equation, it would be 10x minus 35y equals negative 85. And then this one, I need to multiply by 7. I don't have to worry about multiplying either of those by a negative number because these already have opposite signs. So when I multiply that by 7, I get 21x plus 35y equals 119. And you can see I have opposites here now with my y's, so those cancel out. And I get 31x equals 34. So x equals 34 over 31, which is also a fraction. And these could be intersecting at fraction coordinates. It's just easier to do it when it's fractions like this rather than plugging back in, but you could do that either way. So this would be 34 over 31, comma 85 over 31. So there's the solution to that one. So let's talk about the different types of solutions that we can have. So first thing is we could have two intersecting lines. So here's one line and here's another line. These, like I said, are intersecting lines. These lines will have different slopes. If they have different slopes, eventually they're going to intersect. And the algebraic solution, it would have exactly one solution, meaning it's only going to intersect in one point. Our next type of graph would be what happens if they are parallel lines. So if they're parallel lines, we know that they have the same slope. And where are they intersecting? So what is the solution is another way to ask that question. And since these lines will never intersect, this is an example of no solution as an answer. And then the last one is what would happen if we had one equation and then we have what looks like a different equation and we put it in y equals mx plus b form, and it actually ends up being the same exact equation. So these are called coinciding lines. And what we know about these lines is that they have everything the same. Not only do they have the same slope, but they have the same y-intercept. And when that's the case, there are infinitely many solutions. So those are our three options. The lines could intersect, they could be parallel, or they could actually be the same line. Moving on to example 3, this is just a word problem. So it's the sum of 3 times the first number and twice the second number is 8. If the second number is subtracted from twice the first number, the result is 3. Find the numbers. So a good idea when you're doing these is to always label your variables. So x is going to equal the first number, and y is going to equal the second number. And we just need to translate this from a word problem into an equation. So the sum meets add 3 times the first number, so I would write that, and twice the second number, plus 2y, is 8. So is in math means equal, so there's a good hint. If the second number is subtracted from twice the first number, so we take the second number and subtract it from twice the first number, the result is 3. And then find the numbers. So we're not actually going to find the numbers because the challenging part of this one is to set up the equation. I'm confident you could use the elimination method to solve that. So we're just going to go ahead and move on to 7.2, which is solve the systems of equations when there's 3 variables. So these ones sometimes get a little messy because there's 3 variables, but if you just keep your information organized, it shouldn't be too bad. So what we're going to do is we have 3 equations, and so what we're going to do is we're going to take it down to 2 equations and then down to 1 equation just like we did before. So the first thing you're going to do is you can set up this little chart if you like. It's sometimes helpful. Not necessary, but what you're going to do is pick a variable to eliminate twice. So there is a smart choice when you're doing this. So for me, the smart choice would be z's because these two are already opposite of each other, and I can also use this equation if I multiply it by 2 and use this equation down here to eliminate z. You could do x's too, they would be fine as well, and you could even do y's as well, but there's just usually a faster choice. So I am going to eliminate z twice, and the way I'm going to do that is I'm going to take my first 2 equations and I'm just going to add them together. So I'm going to write this, but you could probably save yourself some time if you could just do that mentally. But if you're prone to mistakes, don't do it mentally, write it out so that doesn't happen to you. So when I add these 2 equations, I'm going to get 4x plus 6y equals 28. Put a little box around that or box it off, and now I need to eliminate it twice. So I've already used the first equations, but it's important that we use all 3. So I'm going to start by writing the third equation that I haven't used yet so that I make sure to use it. And I get to pick if I either want to reuse the first equation or reuse the second equation. And in this case, I'm going to reuse the first one because if I multiply it by 2, it has opposite signs of the equation I'm using, and that just makes my life easier. So I'm going to multiply this, everything on both sides, by 2. So when I do that, I get 2x plus 8y minus 2z equals 40. And I've eliminated z again. It's super important in this step that you eliminate the same variable. If you do z for one and x for the other, you haven't progressed at all in your problems, so don't do that. Always eliminate the same variable twice. It doesn't have to be z. You could eliminate x twice or y twice, but pick the same variable. So there's my second equation. So I've taken it down from a system of 3 equations to a system of 2 equations, which I can use either method that we used before to solve. So you're going to pick another variable to eliminate. And for me, since the x's are almost exactly the same, I just have to change the signs. I'm going to pick to eliminate the x. So I'm going to take my first equation, which is 4x plus 6y equals 28, and leave it. And then I'm going to multiply both sides of that equation by -1, and I'm going to get negative 4x minus 5y equals negative 24. Those cancel, and I get y equals 4. So the cool thing about the chart is once you have this, you're going to just make a U-turn and go back the other way. If you have y equals 4, you can either plug that y into the first equation to get your x, or you can plug it into the second equation. I'm going for the second one because it's right near the bottom of my problem and it'll be easier for me to plug in. So I plug in y is 4 and then I solve for x. So when I do this, I get x equals 1, and after I've done that, then I keep going back on my U-turn and pick 1 in there. My personal preference for this is because the variable I have left to solve for is z, I want to pick the problem, the equation where z is most by itself. So you could pick this one since there's a negative, but I don't like dealing with negatives. And you could pick this one, but in the end you'd have to divide by 2. So that's why I'm picking the middle one. But either of the equations will work. So 3 times 1, the 1 is coming from right here, plus 2 times 4, which is coming from where we solved that, plus z equals 8. Combine like terms on one side. So first I'm going to multiply. I get 11 plus z equals 8, so z equals -3. So when I write my solution for this, I'm going to write it in the format of x, y, and z. You might want to look in your book of what this looks like graphically, because it's actually the intersection of planes instead of just lines, because it's three-dimensional, but you don't have to look that up. That's just something interesting to see. So the next one I'm going to put a tricky on because it's definitely going to be on your test. So make sure you just read the directions. What it is it's an application of a system of three equations. And if your teacher had you do the roller coaster worksheet or activity in Algebra 2, then this is exactly what you were doing. It says to find the quadratic function in this format whose graph passes through these points. So again, just because you may not be familiar with how you should even start, because they're giving me points, you could plot them. So you can kind of see the shape of that parabola right there, but that doesn't really help us write the equation because there's no zeros. So what we're going to do is use this information right here. So we need to point out that each of these represents an x and a y coordinate. So I can take the first one, where the y is 4, and plug in 4 for y. I don't know what a is, that's what I'm trying to find, but I know that when y is 4, x is 1. And then I have another x next to the b. So I'm going to write that, which when I simplify this, 1 squared is 1 times a is a, so I get a plus b plus c equals 4. And I'm just converting it to standard form for later. So now I'm going to do the same thing with the next point. When y is 1, x is 2. And that's going to give me 4a plus 2b plus c equals 1. Again, make sure you follow order of operations where we need to do exponents before we multiply by a. And then on the last one, I end up with 9a plus 3b plus c equals 4. So here's my system of equation in three variables. It's not x, y, and z like we just did in the previous problem, but it doesn't matter, you're just naming a variable. So if I can find out what a, b, and c equal, I can plug in those coefficients and get my quadratic equation for this set of points. So I'm just going to do like I did in the last problem, and I'm going to first write my three equations that I just found. And I'm going to pick a variable to eliminate. You can see the easy choice hopefully in this one. I'm going to eliminate c twice. So the way I'm going to do that is I'm going to first take this equation right here and multiply both sides by -1. And the reason why I'm picking that one is because it looks really easy to multiply by -1. So I get -a minus b minus c equals -4. And then combining it with the second one, and then adding those. So the c's are eliminated, and I get 3a plus b equals -3. So there's the first equation. I'm actually just going to reuse that -1 again. So -a minus b minus c equals -4. So the first time I used those two, and so now I'm going to use this one. 9a plus 3b plus c equals 4. And when I do that, the c's are eliminated again, and I get 8a plus 2b equals 0. Don't be freaked out that you got 0. It's okay. It's just a number. So now between these two, a and b, I need to pick a number to eliminate or a variable to eliminate. So I don't want to do the a's because I would have to multiply both of them. So I'm going to do the b's, and what I'm going to do is multiply both sides of this one by -2. So I'm going to eliminate b here. So I get -6a minus 2b equals 6. And then from this one, I have 8a plus 2b equals 0. Those are eliminated, and I end up with 2a equals 6. Divide both sides by 2, and I get a equals 3. So my leading coefficient is 3. Then I'm going to come back in here, pick one to plug into. I'll pick the one that's right at the bottom because it's easier to see. So 24 plus 2b equals 0. So 2b equals negative 24. So b equals negative 12. Okay, and then I'm going to take that and plug it in here, and the one I'm going to pick is the first one. It just looks the easiest to me. You could pick any of them. You could pick the last one. It's up to you. And then 3 and negative 12 make negative 9. And then add the 9 and I get c equals 13. Now in this problem I'm not going to write it as coordinates. I'm not going to write 3, negative 12, 13 like I did in the previous problem because this is not what it's asking. It's asking for the quadratic function. So I'm going to write that equation, but I'm going to fill in my a, b, and c. So it's going to be y equals 3x squared, since a was 3, minus 12x, since b was negative 12, plus 13. So that's that problem right there. So that was the problem for 7.2, and now we're on to the last part, which is 1.9. This is the distance formula, the midpoint formula, and the standard form of a circle. So I'm going to let you know that these formulas will not be given to you on your test, so you should memorize them. I'll show you a cool way to memorize the distance formula in just a second. And then standard form of a circle you should also know. You guys did this in conics in Algebra 2, but we only do circles of this form, so you don't have to worry about conics showing up a lot in Honors Pre-Cal. So for this one, to find the distance between the 2 points, you really just have to know the formula to plug it in. So what you're going to do is I would call this one x1, y1 because it's in the first point, and I call this x2, y2 because it's in the second point. And then I'm going to go 1 minus negative 4 squared plus negative 3 minus 9 squared. And then from this point it's just simplifying. Make sure you simplify all square roots, and you simplify following order of operations. So parentheses first. You can notice I'm carrying over my square root if I don't make it long enough. So I get 25 plus 144, which is the square root of 169, which is 13. So it doesn't always have to be a nice clean number like that. It can still have a radical, but there you go. Over here, I just wanted to point out that that equation right there is just the Pythagorean theorem. So let me show you what I mean by that. So if I have a graph of these points, negative 4, negative 4, 9 is here, and the point 1, negative 3 is here. And the question you're being asked is, what's the distance between those 2 points right there? So what I can do is drop down a perpendicular to the x-axis and draw one perpendicular to the y-axis and make a triangle. And again, I want to know what this distance is here. But what I do know is that the distance in the x direction is 1, 2, 3, 4, 5. So this is 5. So from this point to this point, I had to go right 5. And from this point to this point, I had to go down 12. And you can see that right there in our formula. So the distance formula is just calculating that using subtraction without you having to draw a picture. But let's say now if I asked you what would the distance, or use the Pythagorean theorem to find the length of that triangle, and you would probably go, oh, a squared plus b squared equals c squared. And you have to recognize that c is always the length of the hypotenuse. So when you do it this way, you get that c is equal to plus or minus the square root of 169, but because we're talking a distance, you don't do the minus, so we just get 13. So that's pretty cool. So if on the test you forget to memorize the distance formula, but you remember that it's really just the Pythagorean theorem, you can use that as well. Moving on, now we have this midpoint formula. Notice the midpoint formula is just averaging the two x coordinates and the two y coordinates to find what's in the middle. That's how you find an average. So I keep saying, oh, you have to memorize, but really it's not that big of a deal. So in this one right here, you take your x1, y1, and your x2, y2, and add them together and divide by 2, and then your y coordinate is your y1 and y2 added together and divided by 2 to find the average. So now you just have to do some math. Negative 2/5 plus negative 2/5 is negative 4/5, but it's still being divided by 2 because it's a midpoint. And then this one's going to be 3/15 divided by 2. So if you want, you can reduce that 3/15 to 1/5 at this point, or you can do it later. It's up to you. What I want to point out now is because we have fractions within fractions, we just need to copy dot flip. So this is really 2/1, copy dot flip, copy dot flip. So when we do that, I'm leaving it as 3/15 for now. We get negative 4/10 and 3/30, which we always reduce our fractions. So this would be negative 2/5 and 1/10. So there's how you do the midpoint formula. The last thing for today is going to be circles, and we should be pretty comfortable with this because all it is completing the square. So notice you have two perfect squares. You have the x perfect squares and the y perfect squares, and then the radius squared. So the center of this circle is going to be HK, whatever's in with the x, whatever's in with the y, and then the radius is going to be r. So you have to square root it to find r. So it says write the equation in standard form. So we need to do these perfect squares. So what you're going to do is you are going to take the x's and group them together. So I took x squared and minus 4x plus blank plus y squared minus 12y plus blank, because we're completing the square. And then we have this minus 9. We're going to add it to the other side. But because I added 2 blanks to the left side, to preserve the equality, I have to add 2 blanks to the right side. So then we complete the square. So half of negative 4 is negative 2 squared is 4. What I add to one side, I add to the other. So that's x minus 2 squared plus half of negative 6, or half of negative 12 is negative 6, and negative 6 squared is 36. So I'm going to add that to both sides, which is going to give me y minus 6 squared. And when I add all those numbers up, I get 49. So this right here is my standard form of my circle. From that, it's really easy to see my center. It's going to be 2, 6. Why do I take the opposite of the y when this whole chapter, whole class, we haven't been doing that because this isn't solved for y anymore. So that's why we are going to do exactly what the definition says, and it says if it's minus h, it's just h, that's your x coordinate, and minus k is your y coordinate. And then the radius, to find the radius, we do the square root of 49, which is 7. And I just want to point out, just in case you forget this, if on the test I gave you something and the radius was radical 13 and you were like, oh my gosh, how do I graph that? Just remember it's in between the two perfect squares of 9 and 16, so it's somewhere in between 3 and 4. It's a little bit closer to the 16 than to the 9, so we would say maybe it's about like 3.6 or 3.7. That is not this problem, but I just want to point out, pick up on the hint if you will. And then the last part says to graph it, so what we're going to do is we are going to graph this. So the center is at 2, 6. So we don't have graph paper, but we're okay. So here's the center. And I have to go out 7 in every direction. So go out 7 from the center. Go up 7 from the center. Go left 7 from the center. And go down 7 from the center. And as best as you can, make your circle. That does not look like a circle. It looks like an alien head, but that's okay. Alrighty, that's it for today. Have a great day.